Hello, Geometry. Welcome to the first lesson, video lesson for 1.1. This is Big Ideas Math. And I'm going to try and work to keep these videos 10 to 15 minutes, but mostly I'm going to try to get as many examples as I can in that time as well and not try to leave that short. So sometimes they may be shorter, sometimes it may be longer. And as we get into harder lessons later in the year, they very well could be longer. But this is your instruction. This will give you a head start and an idea of what we're going to be working on the next day. What we do in class will try to be a lot of the work, the assignments, and there'll be some additional examples. What I'm going to be working through is your student journal, and what I expect from you is to be filling it out, filling out definitions, working through the examples. If you feel you know what you're doing, stop the video, try to work an example, and then jump in and see if you did it right. So you don't have to, I don't want you just writing down what I write. I want you thinking. I want you processing in your mind, okay, what's going to be next? What is he doing next? Where's this going? Okay, and even try to beat me there to see if you can get there ahead of me. So we're going to start in geometry and start with the very basics, okay? We have three things that comprise almost all of geometry, and there are points, lines, and planes. And those three things are what we're going to be calling undefined terms, okay? They're what they are. Points, lines, and planes, it's what it is. Okay, it's a point, it's a line, and it's a plane. They don't have a definition other than the object that they are, but there is an agreement of what they do. One of the websites we'll use throughout the year, bring it up here, is desmos.com/geometry. This is a geometry building tool. So I'd encourage you to go there and check it out and basically just play around with it. You can log in using your Google school account, so just log in with Google if you're on your Chromebook. Make sure you're using your school account to do it. And you notice over here on the left, this is where your points, lines, polygons, circles, you can make all sorts of different shapes here. Points, segments, lines, and rays. Those are the four things we're going to do now. Okay, so notice that if I select the point, and what I've done here is up on the wrench, I've turned on the grid, or you can turn on projector mode, that helps you see it a little bit better for me. And I'm going to just put a point here. Okay. Now notice with my point, if I select it, I can label it. And this is how we label and name points. This would be referred to as point A. Okay, it's a specific location in space, so point A. From points, if I do 2 points, so if I start here at A and I go over here and I draw the line between it, now I have a line segment. Okay. Now I have a line segment, and I can label that. There's AB. So this would be line segment AB. I can even select that, and I can label that. I can have a length. So a line segment can have a length. It's called the magnitude of it. Okay. Compare that to a line. So if I select the line tool, you notice if I go from here to here, the line goes through there. A line does not end. A line segment has endpoints. So these are called endpoints. It's where a line segment stops. These are points on the line, but they are not the endpoints. Okay, I could cut this off and have line segment CD, but I have line CD right here. So this is line segment AB and line CD. Now if I select this, notice I can't do a label. I can't measure the length of this line because it goes on forever in both directions. So we have points. 2 points can make a line segment. 2 points can also define a line. There's your definition of that. And then we also have a ray. A ray is an object that starts in one direction and goes forever in that direction. Okay? So again, we can give our labels here. Label that. Label that. Okay, and notice I can move this around, and this ray can be any direction. Okay, let's lock that one. And see, I can have ray EF. A ray is always named with the end point first and then the direction that it's going. So this would be ray EF. And even if it's like this, it's going to be ray EF. Start with the end point, go in the direction that it's going. Okay, so points, lines, and planes, that's what we have here. So on our example, this is page 2 in our student journal, we have a point right there. So this is point A. That's just a point. This right here, this is your segment. And it's going to be called segment BC, and you just put a single line on there. So it's segment, and so that's segment BC. This one is our line. So if I have DE, I'm going to put a line with arrows on it. So this is a line, having the arrows on it. You have to put the arrows on there for the line. And then finally, this one right here, this is a ray. See how it starts at F and it goes to G. So it goes F, G. This is a ray. And a ray has one arrow on it. And it always looks like this direction. It's always pointing left to right, no matter which direction the ray is going. So if I have a ray going this way, and this is E, and that's D, so here's my ray, I would call this ray ED, and it'd go like that. That'd be the name of it right there. Okay? Now we start talking about planes. These are planes right here. Two planes would intersect in a line. Okay? This is the name of the plane right here. Name. So this is plane Q, and here is another name. This would be plane P. Points A and B and line AB are included in both planes. Okay? So these little corners, up in the corners here, a lot of times, if there's not a point next to it like this, okay, that is point A. There's no point written next to this. That means it's the name of a plane. Okay, you can read through those. So here's a lot of terminology, and I want you to get these filled out. Some of these are going to be in your core concepts that are on page 5, on the next page. Some of them are not. They're just in your textbook. You can look at your glossary. You can use the online textbook, or you can use a textbook from the classroom as well. It doesn't matter to me what you use with that, but I want these filled out. Okay, so we've talked about the ones with dots are going to be ones that are in the textbook. They're not necessarily in the student journal. Okay, so in your own words, you can look up your definitions, but these need to be filled out for the next day. Okay, I'll do a few of them. I'll do the ones today that aren't in the student journal. So undefined terms. These are words with no formal definition. But their meaning is agreed upon. So everyone agrees what they are, but they don't really have a definition. Okay, points, lines, and planes. Collinear points. Collinear, there's that linear. You see the word line in there? These are points that lie on the same line. Points that lie on the same line. So that could be, if I have a line here, X, Y, and Z. They would be collinear. Okay? Any 2 points would be collinear because through any 2 points you get one line. Coplanar are points in the same plane. So you can draw a plane. A lot of times it looks like a parallelogram or something. We can call this plane X. And I could have A, B, and C. A, B, and C would be coplanar points. And I could also call this plane ABC. Okay, you can say plane ABC if these 3 points are non-collinear, not in a line. Because if you have a line, you have an infinite number of planes through that line. But if you have 3 points that are non-collinear, then you have one specific point, one specific plane. Okay? So define terms. Terms that have a definition. That kind of cop out there using definition in the word define. But a line segment, or just a segment. Endpoints, we've talked about that. Rays. Opposite rays. 2 rays that have the same endpoints. They have to have the same endpoints. And they have to point in opposite directions. Okay, this looks like a line. And we'll see this later in this lesson. Okay, so two rays that have the same endpoint and they have to point in opposite directions. Intersection where two things overlap. What they have in common. Okay, just think of two roads that have an intersection. Okay, it's the part of the road that they overlap. They both share. Okay, so here's a lot of the definitions here. A point, no dimension, and it represents this. So a point does not have a length and a width. It's an infinite location in space. Now what's new here on lines, it has one dimension. It's represented by a line with two arrowheads, but it extends without end. It goes forever. So that's what it means, extending without end. It's going forever. Now notice this little cursive L up here. This can be other letters, but they can be used to name a line. So they can call this line L, or it can be line AB. You see the AB with the line with the two arrows on top of it. Or BA. So AB and BA are the same thing when it comes to lines. They're not the same thing when it comes to rays. But that's okay to switch those letters for lines and segments. Okay. A plane has two dimensions. So lines have one dimension. A plane has two dimensions. Okay. A length and a width. A line just has a length. Okay. A plane has a length and a width. Notice how they named it. Plane M. There's the M. Notice there's no point written next to it. Or plane ABC. Okay. Three non-collinear points. So this is what it means here. Through any points not on the same line. That is the word non-collinear. There's exactly one plane. You can use 3 points that are not all on the same line, that are non-collinear, to name a plane. So if I have a plane here, it's an S, not a 5. Okay, so I can call this plane QRS or SRQ or RSQ or RQS, any of those directions. Or I can just say this is plane A. Okay, notice the A does not have a point with it, so it is the name of the plane. These are our defined terms, segment and ray. Okay, so here's line AB. Now the line segment has a definition. It consists of the endpoints A and B and all points on line AB that are between them. So you just have an endpoint, and what's between there. Okay, that's a segment. It has a defined length. Okay, you can measure a line segment, you cannot measure a line. Okay, a ray has an endpoint going in one direction. So this one here, notice it starts with A and it goes to B, so that'd be ray AB. This one starts with B and goes in the direction of A, so that is ray BA. So always go with the end point first. So it's going to go in this direction, end point, and then direction. So that's how you name them. It always goes, that always points to the right. Opposite rays, if point C lies on AB between A and B, so here's point C between A and B, CA going this direction and CB going this direction are called opposite rays. Okay? So you notice they have the same endpoint. They're pointing to the right and they're pointing to the left. Okay? So let's look at this. Are these opposite rays? Let's call this ABC. So are BA and BC opposite rays? Okay. Well, now you notice it starts with C line on a line. Okay. So this would be, the answer to this would be no, B is not on AC. So B is going to be the middle. That's the starting point for each of those. It's not between the line that is AC. Okay, you could draw a line between A and C. B is not between them. So these are not opposite rays. Okay, a few more examples here. Use the diagram. Give two other names for line CD. So here's line CD. Now these dashed marks means it's extending below the plane and it's going forever down. So you like have a sheet of paper and the plane is going through it like that. Okay? So two other names for line CD. Well, you can always just flip them around. You can go DC. That would be the same thing. So you can go CD, go DC, and you see this little letter here. We can say, okay, it's line M, little m. Give another name for plane M. So here's plane M. There's no point. So that's the name of the plane, no point. So we need three non-collinear points. So I cannot use A, C, and B because they are on the same line. I cannot say plane ACB. But here's E. I could go plane AEC, or I could go AEB, or CEB. Any of those options would work. Those are actually three options there. Name 3 points that are collinear, so in the same line. Then name a fourth point that is not collinear with these 3 points. So 3 points that are collinear, just kind of talked about this, would be A, C, and B. Non-collinear would be E or D. Okay, that would work. Do not use these italicized letters as points. The little m and the big M are not points, they are names. Name a point that is not coplanar with points A, C, and E. Well, A, C, E, and B are all in the same plane, so that has to be point D. What is another name for line PQ? It's easy. Flip it around. QP. Okay. PQ. We could also say TQ. That would work. Or we could say PT, potty training. That would work. Okay, so 3 options. Again, the TQ and PT, you can flip those letters around as well. What is another name for line RS? Well, easy. SR. Flip it around. Okay, or TS, or ST, or RT. With lines, it doesn't matter the order in which you put. Basically, just rays. Name all rays with endpoint T. Which of these are opposite rays? Okay, so here's my endpoint T. You should be seeing 4 of them. T to R, T to P, T to S, T to Q. So we have TR. Okay, I'm going to put a point, and it points to the right. TR, TP, TS, and TQ. Okay? So TR and TS are opposite rays. So those two are opposite rays. And then TP and TQ are opposite rays. Okay? Because they make a same line. T is between those 2 other points. On the diagram, draw planes M and N that intersect at line K. Okay, this is where we start getting a little tricky. So we're going to draw planes that intersect. How do we do that? Okay, here's line K, and we're actually going to draw kind of an X. And they have to intersect at line R. Okay, drop these lines down, and we're going to shoot to go through line S. And when I go out the back over here, it's actually dashed because it's going to be in the back. Okay, plane M and plane N. Okay, see if you can kind of see that. You have to turn on your 3-dimensional glasses. Okay, here's plane M. Here's plane N. They're intersecting in line K. Line P, line J is going to be in line M. Okay, so line J is in line M, N. Line K is in lines M and N, and both of them. Okay. So sketch the figure described. Line AB and ray BC. So line, segment AB, and ray BC. So they both have B in common. They don't have to be opposite at all. You could put them in the same line. Line K in plane M. So plane M, you're going to draw a parallelogram. Plane M, and I'm just going to draw a line in there and call it K. This is not a point, so it just goes kind of at the end That'd be line K in plane N. Okay, so that takes care of the practice. Here, we're going to have an assignment working online tomorrow, or the next day we have class. And so keep that in mind, that some other questions may pop up that aren't exactly like this, but you have to try to apply them and try to work through them. You'll have your partners to work with, and also I'll be around as well. So I'm trying to get the homework done in class where I can help you if you have any questions. And these lessons are going to be your assignments to complete outside of class. So let me know how this goes for you. I'll ask for your feedback and how we're doing with this on the next day that we meet. But we will see you soon. Bye.